The physics behind strength training and the bench press. The basics of all motion in physics starts with Isaac Newton's 3 laws of motion. The first law being that an object at rest or in motion will continue to be in motion or at rest until an outside force acts on the object. Newton's second law of motion states that the acceleration of an object is directly proportional to the force of an object and inversely proportional to the mass of the object. Newton's third law of motion states that for every action there is an equal and opposite reaction. Diving further into Newton's second law, we will need to understand the standard for the acceleration due to gravity on Earth, which is 9.8 meters per second squared. This is because, as said earlier, the acceleration of an object is directly proportional to the force of an object and inversely proportional to the mass of the object, better stated as the equation to find force, which is the mass of the object times its acceleration equals the force, as seen here. Let's do a quick example problem where the mass is 2 kilograms and the acceleration is the acceleration due to gravity at 9.8 meters per second squared. We plug these values into the equation and we get the force, which is 19.6 newtons of force, created. Now, take a second and pause the video and answer this question. If you got 196 newtons of force as your answer, you are correct. If not, maybe rewatch the example from earlier. Another very important concept in physics is vectors. Vectors represent two values in physics, one being the direction of the value and the other being size or magnitude. When labeling a vector in an equation for physics, you would place arrows above the variable, which shows you it is representing size and direction. As you can see in the equation above, force and acceleration are vector values, but mass is not because there is no direction on mass, but there is when talking about force and acceleration. Now pause the video and answer question 2. What two values do the vectors represent? If you said vectors represent size and direction, then you would be correct. You can continue. Now, putting all previous information together, we can talk about work in physics and weightlifting, as well as proper form for the bench press. When you lift anything, you do work. Work is found by the equation force times distance equals work, or as stated here on the sides of the stick figure, W equals F times D. When you lift the object and do work, you store potential energy. And then when you drop the object, you release that potential energy as kinetic energy of the object. We go further into this in the next video if you're interested in learning about potential energy and kinetic energy. But back to work. When lifting something, you are working against gravity. As said earlier, you can find this work by using the force against the object and the displacement or distance the object has moved. As you can see from the bench press lift, the lifter is working against gravity to push the barbell and weights up a certain distance. To perform this exercise properly and safely, practice proper form and only use weights you are comfortable with using. To perform the bench press properly, make sure the weights move straight up and down and that it is in between your sternum and upper chest, but never above your shoulder joint, as you can see here in the video and photo. Now, using the equation for force and for work, pause the video and solve what work is done to bench 225 pounds or 102.06 kilograms, a distance of 0.5 meters. If you got a value of 1,000 newtons for the force and then use that in the equation for work, you should have gotten 500 joules of work. Thank you, and I hope you enjoyed the video.